Would you get this right on your next exam? Here's the answer in 3, 2, 1. So if you weren't told that this is for an SN1 reaction, the way that you can tell is just by looking at that nucleophile. So rank the reactivity towards, we know this is a nucleophile because these must be substrates, right? They're the alkyl halides. What type of nucleophile is it? Is it weak? Is it strong? Well, it's a carboxylic acid. I know that these are actually weak. This is also neutral. So because it's neutral, I know it's an SN1 reaction. And because we know it's an SN1 reaction, the two things we're going to be focused on are the leaving group. So the first thing is the leaving group, Lg, and this is iodine was first, then bromine, then chlorine. The second part here is going to be the formation of the carbocation, and this was still going back to what we just talked about, what is preferred for a substrate. So this could have been something that's allylic, then it would be tertiary, then it would be secondary, and I don't even want to put primary. But we know for an SN1 reaction, primary is going to be the worst, if that even occurs. Again, that would only happen if there is a carbocation rearrangement. So for each one of these, let's actually draw the leaving group leaving and draw the carbocation. So all I'm doing is I'm saying all of the leaving groups here are taking off, and I'm going to draw the carbocation. So this carbon chain would stay the same, and notice that these carbon chains are all the same, so I'm going to have the same type of carbocation. And let's just put a plus here. I know that the plus sign or carbocation is there because this is where that leaving group is leaving, and that's what that would be. What about this one? Okay, it would look something like this. Leaving group left, I now have carbocation there. Same concept with the next one, looks pretty similar. However, I do have a double bond here. And the last one, the carbocation would be here. Okay, next thing, let's just identify what that carbocation would be. So what would this one be? Well, this is the carbon that we're looking at. It's touching 1, 2 carbons, so that's secondary. So, okay, this is secondary. So all of these would be secondary since they're the same thing. What about this one? So this is the carbon in question that has the plus sign. That's the carbocation. This is touching 1, 2, and 3, so that's tertiary. Same concept here. This is tertiary plus this has a 1, 2, 3 relationship, so that is allylic. And remember, if something is allylic, that's often your tiebreaker as well. And this last one, well, this is the carbon in question. It's only touching 1 other carbon. That's primary. Okay, so we have a few tiebreakers that we need. First thing I would say is, well, I know the carbocation that is going to be the best would be this one. So anything that's tertiary plus it's allylic, yep, that's even better. And I notice that the leaving group is the best leaving group. So that's going to be the most reactive. This is going to be 1. Again, that's because we have iodine as our leaving group and it's allylic and tertiary for the carbocation. Okay, what about the next one? Well, this is tertiary. That's going to be the best. Same with this. This is going to be the best leaving group. That's going to be 2. Okay, I know this is the worst, and I have secondaries here. So the tiebreaker is now going to be the leaving group. Leaving group, that's the best, is iodine. So this is 3. After that, it would be bromine. So this is 4. Then chlorine, that's 5. And I know that since this is primary, this is the last one, and that would be it. This is just one example from my Organic Chemistry 1 course. Click on the link below to start understanding organic chemistry today.